My name is Alanwar Taksali, and I am from the design team of SPAM. In this video, I will be demonstrating my floor cleaning robot simulation in Tinkercad. This robot consists of multiple systems working together, including the wheels for movement, mops and brushes for cleaning, vibration motors for enhanced scrubbing, and a water tank system for dispensing water. Let's go through each section and see how they work. First, the wheels and navigation system. Let's start with the wheels. So, the robot uses a L293D motor driver to control the two hobby gear motors, allowing it to move forward or backward. Additionally, by using the two ultrasonic distance sensors, it determines whether the robot should move forward or go back. Look at the code. We can see that the L293D motor driver controls the left and right wheels using the 4 input pins. The enable pins control the speed of the motor, and the two ultrasonic sensors detect the obstacles by measuring the time sound takes to return. Then, all the pins have been configured as either input or output pins, and the serial communication is used for debugging of code. Then the function to measure distance using the ultrasonic sensors sends a trigger pulse to start the ultrasonic movement and uses the pulse in to measure the time taken for the echo to return, which converts the time into distance in inches. Now, the main loop function, we can see that it continuously reads distance from both the ultrasonic sensors and prints the value in the serial monitor over here. Upon all of this, then, if the front is clear, the robot moves forward at 80% speed. If an obstacle is 5 to 10 inches away, it slows down. And if an obstacle is closer than 5 inches, the robot stops. Now, if the back is clear, it reverses and returns. If both front and back are blocked, it stays in place. Taking a look at the movement forward codes, we can see that each of these functions have been defined, so the robot can either move forward or move backward if it needs to stop, or even turn right. Now, if we simulate the code, we can get an idea of how this works. As we can see, currently both the front and the back motors are below 5 inches, so the motor is stopped. Now, if we increase the front sensor, we can see that both the motors have started to run. And now, if we decrease the front sensor to around 7 inches, we can see that the motor is running at 50% speed. Let's talk about the mopping and brushing system. This section also uses an L293D motor driver to control 2 DC motors, one set for the mop and one set for the brush. These motors spin continuously to simulate a real mop and brush action. Moreover, to enhance the cleaning process, 2 vibration motors have been added, and they're controlled via transistors and are activated at the same time as the mop to improve scrubbing efficiency. And on top of all of this, a crucial part of the cleaning process is the water flow. The robot has a water tank simulation where 2 pumps, which is represented by the LED and the DC motor over here, are controlled using an enable pin. Pump turns on for a few seconds to release water and then stops automatically before the mop and brushes start. So now, taking a look at the code, this code controls the mopping, brushing, and the water tank system. We can see that in the pin setup, by using the L293D to control the mop and brush motors, as well as the water tank system. In the void setup, we can see that all the pins have been set to being an output, and the serial begin function is being used again to debug and simulate in the serial monitor what is happening. In the void loop function, we can see it first starts off by simulating the water flow and printing in the serial monitor that the water flow prints started. Moving on, after a delay of 3 seconds, the water flow stops, and then after 2 seconds, the brush and mop motors start, which the speeds have been adjusted to work at around 180. And then at the same time, while the mops and brushes have started, the vibration motor starts. After 5 seconds, the motor stops, the entire simulation ends, and waits for the next cycle. Now, let's simulate and take a look at how this code looks. Once starting, we can see that the water flow has started, and this LED lights up. Then, after 2 seconds, the motors start. We can see that both these motors, the mop and the brush and the vibration motors, are running. Stops again, and then we can see that the LED lights up. And all the functions are being mentioned in the serial monitor. So to conclude, in this demonstration, I showcased how the floor cleaning robot works, using hobby motors for motion, ultrasonic distance sensors for navigation, and using DC motors for the mop and brush, and vibration motors for efficient cleaning, as well as using a DC motor to simulate a water tank system. Thank you so much for watching.